So hello everyone. So in the lecture 4, we have discussed the Cauchy-Schwarz inequality. Now we'll discuss the length of or norm of vector in using the dot product, and we'll prove the triangle inequality using Cauchy-Schwarz inequality. So what is the length or norm of a vector? So let capital A equals to a1 to n, then the length or norm of this vector capital A is defined by norm of A equals to A dot A square root, or one can basically this is A dot A. So if n is equal to 2, then norm of A is square root of a1 square plus a2 square. So if n equals to 3, then norm of A is a1 square plus a3 square. For example, if a equal to 0 comma 0, then norm of this is 0. A equals to 1 comma 0, then norm of A is square root of 1 square plus 0 square, which is 1. Similarly, if A equals to 0, 0, 1 to 0, 1 is at the ith position, then norm of A is 0 square plus 1 square plus 0 square, which is 1. Okay, so these are called the unit vector. If their length or norm is 1 of some vector, that is called the unit vector. Okay, so this norm also has some property. What is the property? So let A belongs to Rn and C belongs to R. Then norm of A is positive. A is not the zero vector. This is positivity. Norm of A is equal to 0 if A is the zero vector, and norm of CA is modulus of C into norm of A. This is called homogeneity. Okay, so we'll prove these things. For the first one, what is norm of A? We'll start from square. This is basically A dot A, which is always positive if A is not the zero vector by the property proved earlier. That means and that says that norm of A is strictly positive if A is not equal to 0. For the second one, what is norm of A square is A dot A, which is again 0 if A is the zero vector that was proved earlier. That means that norm of A is 0 if A is 0. The third one, norm of CA is square is CA times CA, which is the distributive property or the homogeneity property that we proved earlier. This is square into norm of A square. That means norm of CA is modulus of C into norm of A. Okay. Now we have the triangle inequality. Which we prove now. So let A and B are two vectors in Rn, then less than equal to norm of A. norm of B. So the proof is, we claim that norm of A plus norm of B whole square is less than equal to norm of A plus norm of B whole square. Because if we can prove this, we can actually say that that means that norm of A plus B is less than equal to norm of A plus norm of B. Okay. So what is the left hand side? Is norm of A plus B whole square. So by definition, this is A plus B dot A plus B. Now use the distributive property basically. So we'll get that this is equal to A dot A plus 2i's of A dot B plus B dot B, which is norm of A whole square plus 2i's A dot B plus norm of B whole square. By the Cauchy-Schwarz inequality, in short I write CS inequality, we get that this is less than equal to norm of A whole square plus 2 into. So Cauchy-Schwarz is basically A dot B. This Cauchy-Schwarz is A dot B whole square is less than equal to A dot A into B dot B. But this means by the definition of norm is this. Okay. So from here we will get that A dot B is less than equal to norm of A into norm of B. So we can just write this plus norm of B whole square. So this is norm of A plus norm of B whole square. Okay. So which is the right hand side. So what we proved is that norm of A plus B is less than equal to norm of A plus norm of B, right from there. Now if the equality holds, okay, so from here only we have got an inequality. Before this there was equality. So if the equality holds, that means if this is equal to this, or that means this whole square is equal to this whole square and the vice versa. So if x is equal to y, x square equal to y square, at least for non-negative x and y, which is the case here, and if x square equal to y square, then x equal to y also. Okay, so let x equal to y, then we have x square equal to y square. X square equal to y square means this has to be equal in this step. That means we are using the equality sign in the Cauchy-Schwarz inequality. So if norm of A plus B is norm of A plus norm of B, then by the above steps, A dot B is equal to norm of A into norm of B, which gives by the CS inequality that A equal to C times B for some scalar C. So A and B are scalar multiple of each other. So this is a very important inequality, and geometrically this says that you have some two vectors, one is A, let's say this is A, and you have another vector, this is B, this is A, this is B. So this is the parallelogram, this is also B, this is A. So this is the norm of A, this is the norm of B, okay, length, and this is the vector A plus B, this is A plus B, and this is the length of the vector A plus B. So it says that this triangle inequality says that the length of one side of this triangle, okay, cannot exceed the sum of the lengths of the other two sides. Okay, this is the, so what it says is that the length of one side of a triangle does not exceed the sum of the lengths of the other two sides. Okay, yes.